For 200 years, there's been this giant wall in mathematics, a you shall not pass sign for a whole class of problems. But what if I told you that someone claims to have just smashed right through it? That's what we're diving into today.
And really, this is the big question, isn't it? What if something we've all been taught is impossible isn't actually impossible? What if it's just been a huge 200-year-old misunderstanding because we were using the wrong tools all along? Okay, so to really get how big of a deal this is, you first have to understand the wall itself. I'm not kidding, this thing has shaped the world of algebra for generations. Let's rewind the clock a bit. The year is 1824. Mathematicians are on this huge quest, right? They're trying to find a master key, a single formula that can solve any equation. And then, bam, they hit a brick wall, a limit that would literally define the rules of the game for the next 200 years. And here it is. This is the wall. It's called the Abel-Ruffini theorem, and what it says, in plain English, is this. You know how you can solve quadratic equations with a nice clean formula? Well, you can do that for equations up to the 4th degree, but for the 5th degree and anything higher, the theorem says, nope, it's impossible. There's just no general formula, using the normal tools, plus, minus, square roots, that kind of thing. And look, this wasn't just some small little problem. For 2 centuries, this idea of impossibility became gospel. It was chapter 1 in the textbook. It's what every math student learned, what every professor taught. It was, for all intents and purposes, the end of the story.
But here's the thing about the end of the story. Sometimes, someone comes along and decides to write a new chapter. So, let's get into how this whole idea is finally being challenged.
This is where Professor Murad Sultan Ezoidi comes in. And his claim is, it's huge. He's essentially saying, look, Abel wasn't wrong, but he was playing with an incomplete deck of cards. The problem, according to Ezoidi, isn't that the equations are unsolvable. It's that everyone's been trying to solve them using a limited, outdated toolkit.
This table really lays it all out, doesn't it? On one side, you've got the old school, Abel, Galois. Their methods say it's impossible. The best you can do is get a numerical approximation, which is just a fancy way of saying a really, really close decimal guess. But on the other side, Ezoidi's method says, nope, we can get 100% exact, perfect answers for any equation. He's totally rejecting this idea of mathematical fatalism. It's a completely different way of thinking.
So you're probably thinking, okay, how, right? I mean, if the best minds for 200 years couldn't crack this, what's the secret sauce? Well, it all comes down to looking at the problem in a totally new way. The big idea here is to just bypass the old rules entirely. The classic approach, using something called Galois theory, is kind of like trying to untangle a massive knot by only pulling on 2 or 3 strings. It's just not going to work. Ezoidi's method basically ignores those strings. Instead, it works recursively, layer by layer. It's like it gently wiggles the entire knot until, pop! The hidden structure just reveals itself, giving you those perfect, exact roots. And here's the basic game plan, laid out nice and simple. Step 1. You don't just charge at the equation head-on. You rearrange it, you organize it into these neat recursive layers. Step 2. You apply these special transformations to each layer, one by one. And by step 3, the exact answers, the very things everyone said were impossible to find, they emerge right out of that structure. It's pretty elegant, actually. All right, so this is where the rubber meets the road. It's one thing to have a cool theory, but can it actually do it? Can it solve the unsolvable? Let's see.
And wow, take a look at that beast. That is a 20th degree polynomial. I mean, just looking at it is intimidating, right? With the old methods, the absolute best you could do is get a bunch of long, messy decimal numbers that were close. An exact, beautiful, symbolic answer? Forget it. Total fantasy.
And then there's this. This is a Ezoidi's solution. It's not a long, ugly decimal. It's clean. It's precise. It's a symbolic formula. It's the exact thing that for 200 years everyone said was impossible to find. And you can see how it's built directly from the numbers in that monster equation we just saw. 100%. Let that sink in. Not almost. Not close enough for government work. 100%. Algebraically perfect and verifiable. This isn't an estimate anymore. This is the answer. So, okay, solving one crazy hard equation is cool. But if this is for real, the implications go way, way beyond just one problem. This could change things on a fundamental level.
So why should you care about this?
because it could literally redefine what the word solvable even means. Think about it. This suggests that the answer to every polynomial has been hiding inside the equation itself all along, just waiting for someone with the right key. This isn't just solving a problem, it's blowing the doors off a room we thought was locked forever. It's turning a dead end into a whole new universe of possibilities.
I think this quote just nails it. Abel's theorem wasn't really a wall, it was just a boundary line drawn on an old map. Izuidi's theorem isn't about just stepping over that line. It's about grabbing the map, tearing it up, and saying, we need to draw a whole new one.
And that's where we'll leave it, with this thought. If a mathematical impossibility that stood for 200 years can be challenged like this, well, what else is out there? What other problems that we've given up on are just one new idea, one fresh perspective away from being solved? You have to wonder, what's the next impossible wall to come tumbling down?